What is the engineering behind ablative heat shields for reentry? Imagine zooming through space at thousands of miles per hour and then hitting Earth's atmosphere. The heat generated is so intense it could melt metal in seconds. How do spacecraft survive this fiery ordeal? The answer lies in the clever design of ablative heat shields. These shields are a vital part of space missions that involve returning astronauts or equipment from space. Without them, reentry would be impossible and extremely dangerous. Ablative heat shields work by sacrificing their own material to protect the spacecraft. The outer layer is made from special materials that burn, melt, or vaporize when exposed to extreme heat. This process is called ablation. As the shield material ablates, it carries heat away from the spacecraft, preventing the interior from overheating. Think of it like a candle melting away to keep the flame from burning the table. There are two main processes happening during reentry. First, the outer surface of the shield undergoes sublimation, turning directly into gas. This is like ice turning into vapor without becoming liquid first. At the same time, the material underneath breaks down chemically in a process called pyrolysis. This releases gases that form a protective layer around the spacecraft. This layer acts like a barrier, blocking heat and hot gases from reaching the spacecraft itself. Some ablative materials contain carbon, which makes the shock layer around the spacecraft opaque. This means it blocks thermal radiation, the heat energy radiating from the atmosphere. This helps prevent the spacecraft from heating up too quickly. These shields are designed for single use because the material is consumed during each reentry. Once used, they cannot be reused, which is why they are perfect for missions where the spacecraft only needs to reenter once. For example, Apollo missions used ablative heat shields that were carefully engineered to burn away at just the right rate. The shields had to be thick enough to last the entire reentry but thin enough to burn away efficiently. The cost of these shields varied depending on size and material but generally ranged from a few thousand to tens of thousands of dollars per shield. The entire process from design to testing could take several years, ensuring safety and reliability. Astronauts learn about these shields during training because understanding reentry safety is part of their preparation. Engineers work tirelessly to balance the heat input and the rate of ablation so that the shield protects the crew without burning away too quickly. This engineering feat is essential for mission success and crew safety. In the end, ablative heat shields are a clever use of material science and physics. They protect spacecraft by absorbing and shedding heat through controlled material loss. This technology is a key part of mission planning and execution, making sure that astronauts and their equipment return home safely from space.